Hey guys, welcome to my channel. I'm GDcoder. If you guys are new to my channel, I pretty much do LeetCode style questions and try to explain things in the most simplistic way possible. And today I have a very interesting problem for you guys. This is a good problem when you first start doing LeetCode because it gives you confidence, that you guys are able to solve problems, right? So let's get into the prompt statement really quick. So it says, given two strings, right, S and T, write a function to determine if T is an anagram of S, right? So we're given those two strings right here, right? And then we need to check if they're anagrams, right? So now, guys, the way we're gonna go about solving this. So pretty much anagrams, first thing first, anagrams are pretty much, if you rearrange the letters of this word, right? And you get another word, they're anagrams of each other, right? Just rearrangement of the letters of one word, right? That's pretty much what anagram means, right? So I'm gonna give you guys a couple examples real quick. So we have race, right? We have care, right? Those two are perfect anagrams, right? Because we just rearranged the letters in race to turn now they're care now. So you see, we just switch spot of R and C, right? We just switch the spots, right? Just switch them together, and but A and E are at the same spot, right? So pretty much rearrangement of the letters for anagram mean, right? So something that's not an anagram of each other, right? So rat and car, right? They're not anagram of each other because we can't rearrange the letters in rat to equal car ever, right? Because we don't have a C in the word rat, so it's impossible to get an anagram of that, right? So guys, the big takeaway that I want you guys to get from that is that pretty much all the characters. So pretty much we have two strings, right? So all the characters, right, and those two strings are their number of occurrences are the same, right? Pretty much what I'm saying, we have the same amount of R's, right? One R, the same amount of A, right? One A, the same amount of C, one C, the same amount of E, one E, right? And this one, we have the same amount of R's in this one, right? R together, same amount of A's, right? The same amount of T, no, not the same amount of T's, there's no T in car, so that's why they're not anagrams, right? So now, guys, I'm gonna go through an example. So pretty much we see that, the letters in both strings, right? Their number of occurrences need to be the same, right? So the way that I'm going to go approaching this problem is to have an array, right, of size 26 that represents all the characters in the alphabet, right? So all the 26 letters in the alphabet. So that's the main reason why I'm going to have an array of size 26, right? So now I'm going to loop through all the characters in the first word, right? Right? I'm gonna look through a lot of characters, and every time I encounter a character, I'm gonna increment it by one, right? And then I'm gonna look through the second string, right? And every time I see a character, I'm gonna decrement it by one, right? And then decrement it by one, right? So in a perfect world, right, we're gonna have it would be zero, right? The number of occurrences would be zero because the same amount of times I'm gonna increment A, right? When I'm looping through all the characters in first string, I'm gonna be decrementing with the same amount of frequency. So that's a whole thought process, right? So let me go through an example real quick with you guys. I think I'll make it a lot easier, right? So pretty much I just copied, the prompt statement and just have it here, right? So now, guys, the way that we're gonna let's go with the algorithm that I've talked about. And yeah, so right now we're gonna loop through S, right? So now we see A, right? We increment it by one, like I said, right? Because when we're looping through S, we're gonna increment all the number of occurrences, right? So right now, once we're looping through S, right, we saw A one time, right? And then we see N, right? We increment N one time as well, right? And we see A again. We increment A one time, again, two. We see G, right? G by one, right? We see R by one, right? And we see A again, right? This A. So we increment that by one more. And then we see M, right? M by one again, right? And then now we're gonna loop through all the characters in T, right? So now we have this N, right? We see N, we decrement that by one, right? So it goes back to zero, right? Perfect. And we see A one time, so we decrement A by one, so from 3 to 2, right? And we see G, right? And we decrement G by one. and we see a again, right? We decrement a by 1, now it goes to 1, right? And we see r, right? And then r goes back to 0, right? That's good. And we see a one more time, and we decrement a, so it goes back to 0, right? And we see m, right? M goes back to 0, right? So now we're gonna do another loop, right? But this time we're gonna loop through all the letters in the alphabet, right? All the arrays, right? And the array, all the indices in the array, right? Index in the array. So, but this time we're gonna check if any one of them, right, is not equal to 0, right? Because in a perfect and in two words to be anagrams, right, they need to have the same number of like occurrences, right? So everything will be 0. So we loop through, we see that there's everything 0. So this is a perfect anagram because we didn't have too much of something in one string and not enough of it in the other string, right? So it's a perfect balance, right? So if we have the same number of characters in, let's say the same amount of A's and S, right? We increment A 3 times, right? And then we see the same amount of A's again here, right? It will go, and we decrement it 3 times, so it goes back to 0. So that's why we get the 0, right? And then so let's go through this example, right? So right now we're looping through S, right? So we see R 1 time, so we increment R 1, right? And we see A 1 time, increment A 1 time, right? So it's 1. And we see T, we increment by 1, right? And then now we're gonna loop through T, right? The characters in T. So we see C 1 time, right? We increment that, we decrement that by 1, so it will be at -1, right? So it'll be at -1 now. So because there's no C and there was no C in S, so it was at 0, and it was still at 0, so we decremented by 1 still, right? And then we see A, we decrement A by 1, right? And we see R, and we decrement R by 1, right? 0. So now we loop through everything in the array, right? And we see at this particular location, we got -1. It's not 0, so it's not a perfect balance. So that's going to result in it not being anagram because this means that there was not a C, and there's not enough C's and S. That's why we have a negative number, right? So we return false, meaning not an anagram, right? So let's go through the code now and implement a logic that we just came up with, right? So right now we have this count, right? Array, right? It's called count. It's gonna hold all the letters in the alphabet, right? So now, guys, we're gonna loop through all the characters and in S, right? So S to char array, right? So now this is where it gets important. So how do we know which index the characters fall in, right? We're gonna subtract the characters minus A, right? So whatever character that we're at minus A is gonna give us the exact index that's gonna be right. So A minus A, right? So let's say we got the word A minus A, right? Their ASCII values, right? Subtracted together is gonna give us an integer. So that allows us to know which index that it falls in, right? So A minus A, which is 97 minus 97, that's the ASCII value, right? Will be 0, so it will map accordingly, right? And B, ASCII value is 98, right? So 98 minus 97 maps to 1, right? So it matches perfectly, right? And then once we loop through all the characters in S, we loop through all the characters in T, right? Like I told you guys. So, but this time we're gonna decrement every time we see a character, right? And then now for the moment of truth, right? We're gonna loop through all the characters and all the characters in the array, right? The count array that kept track of all the number of occurrences, right? So now we do and I equal to 0. I is less than 26, right? Because let's just count that length, right? I plus plus, right? So now we have this if statement, right? If any index, right, is not equal to 0, we're gonna return false. So we do if count of I, right, of a particular index is not equal to 0, we return false, right? And then if it never hits the if statement, right, we're just gonna return true. So let's run the thing real quick, see if we pass all the test cases. All right, we passed that small test case. One thing that we need to take care of, right? They need to be the same length, right? So if they're not the same length, we need to do this algorithm, right? Because they're not going to be anagrams, right? Because they need to be the same length, right? So now you do a simple check, right? If s that length, right? S that length is not equal to t that length, right? We simply return false. There cannot be anagrams, right? Press run code, see if we pass that test case. All right, let's press submit to try all the test cases. All right, perfect. Seems like we passed all the test cases. So yeah, guys, I want to thank you guys for taking the time to watch this video. Let me know in the comment section if I did a pretty good job. And if you guys are new here, make sure you guys subscribe, because I will be uploading a lot of videos like this, you know, and I'll explain it in a very simple way. So thank you guys for watching, and I'll see you guys in the next one.